Welcome students. Today again we are going to do chapter number 1, real numbers, concept 2. In the previous video I share you about how to prove that a single number square root is irrational. In the second video we are going to discuss how to solve, how to prove that under root 2 plus under root 3 is a rational number. Okay, so first of all you will suppose that let under root 2 plus under root 3 is equals to p over q, where p and q are co-prime integers with the condition that q should not be equals to 0. So we have supposed under root 2 plus under root 3 is equals to p over q, where p and q are co-prime integer. This means that we are supposing under root 2 plus under root 3 equals to a rational number, because integer upon integer is a rational number. Then what you will do is you will shift under root 2 to the right hand side. Okay, this is the second step. In the first step you will suppose under root 2 plus under root 3 is equals to p upon q, where p and q are co-prime integers. That means we have supposed under root 2 plus under root 3 is equals to rational numbers. In the second step you will shift under root 2 to the right hand side. Third step is that you will do the squaring both sides. It get cancelled. 3 is equals to, now here a minus b whole square, a square plus b square minus 2 a b. Okay, and it get cancels. So 3 is equals to p square upon q square plus 2 minus 2 p over q minus under root 2. Now what you will do is you will transpose this number, this whole thing on the left hand side, and you will bring 3 to the right hand side. Okay, because it is a negative na, so you will make this to be a positive. In order to make it positive, this term, whole term positive, we will shift it to the left hand side. Okay, so here it goes, and we will shift 3 to the right hand side, because 3 is having plus sign. When it will come here, it will get minus. Hope this point is clear. You will shift this negative term to the left hand side, and you will bring this 3 to the right hand side. Okay, p square upon q square minus 1. You will take the LCM here, it becomes q square, p square minus q square, and here it is. Now you will shift to p upon q on the right hand side, it will become reciprocal. When you will shift this term to p upon q on the right hand side, you will get the reciprocal of the same. Okay, so q get cancelled with the q. Under root 2 is equals to p square minus q square upon 2p. Okay, so I'm solving here so that the question remain on a single page. Now on the left hand side you have under root 2. and we know that it is irrational. Okay, and on the right hand side we have p square minus q square upon 2p, which is integer upon integer, and we know upon integer is a rational number. So on left hand side you have an irrational number, on the right hand side you have a rational number. Our supposition is wrong. So under root 2 plus under root 3 is irrational number. Okay, so once again a quick recap. You will assume under root 2 plus under root 3 is equals to p upon q, where p and q are co-prime integers, q not equals to 0. You will shift under root 2 to the right hand side, squaring both sides, applying the identity here. We have applied the identity a minus b whole square, which is a square plus b square minus 2ab. Okay, then solving it, then shifting this minus term to the left hand side and bringing this 3 to the right hand side. 2 minus 3 is minus 1, taking LCM, then shifting this 2p upon q on the right hand side, it will become reciprocal, it get cancelled. Okay, p square minus q, 2pq, 2pq. Okay, so q will also come here, so here also q. So on the right hand side you have, on the left hand side you have under root 2, which is irrational. On the right hand side you have p square minus q square upon 2pq, which is integer upon integer, which is a rational. One side irrational, one side rational, not possible, supposition wrong. So this under 2 plus under 3 is irrational number. You will get this sum for 3 or 4 marks. Okay, thank you very much.